Okay, guys. So we closed out the part one of lesson two with independent and dependent variables, and we talked a little bit about the criteria for causality. So this is lesson two, part two, and we're just going to pick up where we left off. So another example of independent and dependent variables. Let's look at newspaper readership and age. Someone might hypothesize that as people get older, they are more likely to read the newspaper. Or, older people read the newspaper more than younger people. So which one of these two variables, newspaper reading and age, which one of these two variables is the independent variable? The variable that we are going to systematically vary. And which is the dependent variable, the one that we think is being influenced, the one that we want to actually measure, the one that we actually want to explain? Well, in this example, age is the independent variable. We're going to systematically vary it. We're going to have our young people, our old people, our middle-aged people. We can do that very easily, like in a survey. We can just ask people how old they are, and we can divide them up into the categories, right? Um, and newspaper readership is the dependent variable. That's what we want to explain, right? That's what we actually kind of want to measure here. We want to see how much people are reading the newspaper by age, right? Education and prejudice. This is another example. We might assume, we might hypothesize that the more highly educated someone is, the less prejudiced they are. Okay? So, which one of these is the independent variable? Which one is the dependent variable? Well, we think that education level influences level of prejudice, right? So the independent variable in this example would be education level, and the dependent variable would be the level of prejudice, because prejudice depends on um, the level of education that someone has. Okay, um, so that's another example. One more example here: taking medication and health. Health depends on taking the medication. So health is the dependent variable. Taking the medication is the independent variable. I mean that's really general, but like in medicine they would speak specifically or be interested specifically in a particular illness and a particular medication. So um, if someone has an upset stomach, if they take Pepto Bismol, will they feel better? So in that example, the medication, Pepto Bismol, right, is the independent variable, and how the person feels, their condition, is the dependent variable. Okay. Um, Independent variables are sometimes called influencer variables, predictor variables, antecedent variables. Dependent variables are sometimes called criterion variables, but usually they're just called dependent variables. Let's look at some other kinds of variables. We have discrete variables and continuous variables. A discrete variable cannot be divided into subparts. Um, they include word categories such as gender and occupation because they form discrete categories, right? Genders, male, female, okay? You can't divide it into subparts. Um, it could include some numerical categories if they form distinct categories. So, for example, the number of children in a family. You can have 0 children, you can have one child, you can have 2 children, 3 children, right? You can't have 2.5 children, okay? The number of goals in a soccer match is the same idea. There could be 0 goals, 1 goal, 2 goals, 3 goals. You can't have 3.7 goals in a single soccer match, right? So the idea here is there's one specific or discrete value. So these are discrete variables. Oftentimes we work with discrete variables, but sometimes we work with continuous level variables. These are variables that can take on any value, including fractions, and they can be broken into subsections. So for example, the temperature. The temperature can be 40 degrees, it could be 45 degrees, it could be 50 degrees, it could be 40.1, 40.2, 40.25. I mean, it's pretty much infinite, right? So they do not have a restricted set of values that they can take. Height is another example. Someone could be 5'9", they could be 5'9.25", they could be 5'9 1/8", they could be 5'9 1/2". I mean, we can go on and on and on, right? So discrete variables and continuous variables. A very important kind of variable is the control variable, and the control variable is important because it helps us eliminate confounding variables. Remember confounding variables? Confounding variables are those things that there are those variables that mess up your research study, right? So in other words, let me talk about this again because I think this is important enough to devote some time to. Remember, we want to study the relationship between the dependent variable and the independent variable, right? We want to find out if the independent variable actually causes the change in the dependent variable, right? That's what we're interested in. But the idea is that with confounding variables is that there could be some other variable lurking to the outside, right? That's actually causing the change in the dependent variable, right? Or even causing changes in both the independent and the dependent variable, okay? And that's your confounding variable. So I'll give you an example here, and we'll look at other examples during the course of the term. But let's say you want to study the effects of violent movies on people. Specifically, the effects of violent movies on aggression in people. Do people become more aggressive? And you might hypothesize that people become more aggressive after watching violent movies. That might be your hypothesis. So you have two variables here, right? You have the violent movies, that's your independent variable because you think they influence, and then you have the level of aggression, that's your dependent variable. You want to study these two variables purely. You want to be able to isolate them so that you can say with confidence that the independent variable either causes or does not cause a change in the dependent variable. That's what you want to do. But here's what you have to be careful about. You have to be careful about confounding variables. That is, variables that are on the outside, they're lurking, and they might actually be causing the change in the dependent variable. So in other words, you look at this and you go, oh wow, people watched a violent movie, and then yeah, now they're more aggressive. Gee, I guess the independent variable must be having an effect. People are getting more violent. They're getting more aggressive after watching the violent movies, but not so fast. Have you eliminated the confounding variables? Again, there could be something else that's causing the people to become more aggressive. It might be something, for example, it might be you have to control for, this is why control variables are important, because the control variables control for the confounding variables or the potentially confounding variables, okay? So it could be, can you think of another possible cause why people might be getting more aggressive? I already gave you that example of the ice cream cone, right? With the ice cream cone and the deaths by drowning. Clearly there wasn't a causal relationship there. We had a confounding variable, the weather. What about in this example? Could there be a confounding variable? Or might there be some variables that you need to control for? Sure, certainly. How about this? How about upbringing? Maybe these people that are more aggressive they had really rough upbringings. Maybe they're more aggressive because of their environment. Some people actually live in rough, violent environments. And some people live in really cushy suburban neighborhoods where there's no violence, right? So maybe that's actually the cause, right? Maybe that's the cause of why. So you have to actually control. You have to actually ask people, what was your upbringing? Where do you live? What's your current living environment like? Is there a lot of violence and aggression in your life? Um, you'd want to ask about things like education level, their emotional states, and so on and so forth, because there might be something else that's causing these people to be aggressive. That's the idea with confounding variables. So when you do that study, the effects of violent movies on levels of aggression, you have to control for these other variables, these other lurking variables, these confounding variables. And that's what we call them, confounding variables, and we also call them lurking variables or third variables or extraneous variables. Okay? We have to control for all of them. So when you're doing that little study, you actually have to ask people. Don't just ask them to watch a movie and then test their level of aggression. You actually have to ask them about their um, their upbringing. You have to ask them about where they live, their current environment, and about other things. Maybe ask them, do they play video games? Maybe all these people in your study, they're all really aggressive. Maybe they all play Halo 3 or Call of Duty, these really violent video games. That's why they're more aggressive. Maybe it's the video games that's causing them to be aggressive, not the movies, right? So you have to control for, and it's hard work. You have to control for a lot of different possibilities. So you have to think about and anticipate the possible confounding variables. And it's critical because your study could get thrown out. It could get thrown in the garbage. People will criticize. They will beat you to shreds, or they will tear you to shreds, I should say. Your research. If you submit an article to the journal, and you say, oh yeah, I did this study, and I found that people watched this movie, this particular violent movie, and then they became more aggressive. Well, I'm a reviewer now. I'm looking at this. I'm going, I'm not convinced because you didn't control. You did not introduce control variables. And the control variables control for what? The confounding variables. So I'm going to be really doubtful. I'm going to be sitting there going, no, and remember, as a scientist, I'm already what? I'm skeptical. So I'm going to be sitting there going, I'm not convinced that it's the movie that's causing the aggression. It might be something else. And I don't know because this person, this researcher, didn't control for any of these variables. So noise is just similar to the problem of confounding variables. It's just something that interferes with the research process, and that can introduce it can mess up your study basically. So here, this is an example. If you want to test the relationship between newspaper readership and reading ability, we would want to control. So you might hypothesize that people that read really well are more likely to read the newspaper, right? We would have to control for other variables. We'd have to control for intelligence, for example, IQ. And the reason we'd want to control for IQ is because we want to know if there's a true relationship between readership and reading ability, right? And not simply one that's related to IQ. So it could be, for example, that IQ is the true cause of both the increased reading ability and the increased newspaper readership. So if you see a relationship between newspaper readership and reading ability, don't be so quick to say, "Oh yeah, all we have to if they read well, then they're gonna read the newspaper." Right? Don't be so quick. It might be that it's the fact that they're more intelligent. That's why they read well, and that's why they read the newspaper. Sometimes we're interested in multivariate analysis, where we want to study more than two variables. It's not always as simple as I've been making it out to be so far. I've been talking about one independent variable and one dependent variable. But in my dissertation, for example, I studied the relationship between the size of a newspaper article, the topic of the newspaper article, and the newspaper ownership type. So I was able to look at all three of these variables, and this allowed me, for example, to find out whether a government-owned newspaper in Egypt, like Al-Ahram, right, whether Al-Ahram articles that were about a very specific topic, like about the president, were larger in size, right? Why would I be interested in that? because I wanted to find out which newspaper types devoted more attention to certain topics. So I was able to see that the independent newspaper that I studied, that's newspaper type, the independent newspaper that I studied uh, included a lot of really large articles, article size, about crime. They were very interested in crime. And I was able to uncover that in my research. So sometimes we're interested in more than two variables, and I want you to be aware of that. Measurement. We talked about this a little bit last time. We'll again, like I said, we visit stuff and we revisit stuff in this class. So in measurement, we assign numbers, numerals, to certain objects or events or properties according to rules. And that allows us to measure these concepts, these objects, these events, right? We don't just say he's old. We measure it very specifically, right? We say he's 87 years old, right? The temperature. We don't just say it's hot, it's cold. We actually have a very specific, we can say it's 95 degrees today, or it's really cold, it's 12 degrees today, right? We are very specific with how we measure things. And so I gave the example last time about religiosity, source credibility. That's another example. We measure all kinds of concepts. Media bias. It's another concept that we measure very frequently in our field. We talked about television dependence. These are things we can actually set these up and measure them, right? We develop basically a system of rules, and then we can measure, and we give numbers. We have scores associated with these things. Okay. We want our measurement, whatever measurement we set up, to be isomorphic to reality. That means we want it to be as close to the true value as possible. Okay. Let me give you, before I move on to operational definitions, let me try to give you another example of measurement. So in some of the work that I've done, I've been interested in examining how a particular article, a particular newspaper article, frames frames an act of violence. Okay. Actually, let me not. I don't want to take. I don't want to take a high level example right now. Let me give you something a little bit simpler. In some of my studies, I've been interested in measuring the length of news reports, television news reports. Okay, and I have my little scheme. I want to know if these are long news reports, or medium length news reports, or short news reports. And I just develop a rule. I say news reports that are a minute or less, those are short news reports. Between a minute and 2 minutes are medium length, and 3 minutes and above, 3 minutes and more, that is a long news report. Okay? So that's, how did you measure the length of the news report? Well, that's how I measured it. I added up the number of seconds and minutes in the news reports and categorized them according to that rule, right? We'll deal with some more examples, some higher level examples as we go. But for now, I just want you to know that in research, we assign numbers to objects and events and concepts, and that's what allows us to carry out quantitative research. Remember last time I gave the example of religiosity, right? So how would we measure religiosity? It's hard to measure. So, well, this guy's religious. This gal is not religious. Well, how do you know? We want to put numbers to it. We can't just say, well, he's religious. In research, we need to be more, in quantitative research, we want to be very precise. So we would develop basically rules. We would develop a numbering system. We would ask a bunch of questions. We have these religiosity scales that researchers have developed. Do you believe in God? To what extent, or how would you characterize the strength of your faith in God? Very strong, neutral, weak, very weak. So we could ask about belief in God. Do you go to church or do you go to a place of worship? Do you pray? How often do you pray? Do you read your holy book? So on and so forth. And now at the end of this, you have all these numbers. Oh, this person got a 4 for this, a 5 for this, because they're all on scales, right? 1 to 5, right? A 5 would be very strong faith in God. A 1 would be very weak faith in God, for example. We're just making this up. But so at the end, people are going to have scores. We've measured it now. This person scores a 4.5, means he's very religious. This person scored a point 9, means he's not religious at all, right? So this is what we want to do in quantitative research. I'm going to stop here, and we'll pick up the next part of this lesson here at operational definitions.